Hi, this is Craig Norton with Optimal Performance Index System. We're a company that does structural parameter testing and analysis for athletic shoe prototypes and athletic shoes. So it's been a while since we've done a video on our testing, but we thought we would test the structural parameters and analyze a Puma shoe. This is the Puma Fast-R Nitro X. So we're going to test the shoe two different ways. We're going to test it without the insole and with the insole. So just for the sake of saving time, we've already tested it without an insole. So let's take a look at our mathematical model and you can see the results of that. So this is the shoe tested without the insole. Without the insole, it weighed 7.8 ounces. It produced a midfoot stability of 28 inch-pounds, which was in the minimal range. It also tested to have hindfoot stability of 6.94 millimeters. And that was within the minimal range. This midfoot stability is actually in inch-pounds. The next thing is it tested to have a rebound index of 23.72. That is a high energy rebound. With its vertical support, it tested in the minimal range of 1.06 loaded heel to toe drop. Its overall shoe stability index was 39.07, which put it in the neutral stability. So let's go over to our database. At 39, it is way down here in the neutral stability. And this is more performance shoes. This is where the more well-conditioned runners should be. As the shoes move up, they get more stable, and this is where the more recreational type of runner should be, the type of shoes that they should be in. So now we're going to test the shoe with its insole. So we've incubated the shoe so that it's tested at the same temperature as the shoes in our database. We're now going to test for its midfoot stability, for its hindfoot stability, rebound index, vertical support, and then we'll compare it with the shoe when it did not have its insole. So the first thing we're going to test is its midfoot stability. And how we do that is we torque the shoe on its long axis to 15 degrees and we measure the resistance in inch-pounds. The higher the inch-pounds, the more midfoot stability. The less inch-pounds, the less midfoot stability. So let's go ahead and measure that. So that measures about 26 inch-pounds. So let's place it here. And that's in the minimal range for midfoot stability. So the next thing we're going to measure is the rear foot stability. And what we're going to do is to compress the midsole under the heel. And we're going to compress that to 100 pounds. And the more distance it takes to that 100 pounds, the softer the midsole, the less hindfoot stability. The less millimeters it takes to get to the 100 pounds, the firmer and the higher the stability is. So let's get that moving. Now we're in the process of loading the calcaneal block into the midsole under the heel. And we're going to go to 100 pounds. So we have 8.92 millimeters. That's what it took to load this 100 pounds. So let's go ahead and let's put that into our mathematical model. Okay, so now we pretty much have everything. The next thing we need to do is to get the rebound index of this. So what we're going to do is we're going to load the midsole to 100 pounds, release this lever, and this will fly up, and this computer will measure in millimeters how far it went up. And that gives us our energy return. So we're waiting till it gets to 100 pounds. Release the lever, and it's got 24.58 millimeters. So let's put that into our platform. So it's 24.58, and that's in the high range. So if we take a look at this, with the insole, the weight increased by 10.26%. So it went from 7.8 ounces to 8.6 ounces. For the midfoot stability, it decreased with the insole by 7.14%. It went from 28 inch-pounds to 26 inch-pounds. For the hindfoot stability, with the insole, it dropped 28.53%. It went from 6.94 millimeters to 8.92 millimeters. For the energy return, it increased by 3.63%. For vertical support, with the insole, it dropped 186.79%. So with the shoe, with the insole, you had minimal hindfoot stability, and you had a negative vertical support of minus 0.92 millimeters. With those parameters, we do not recommend the shoe for those that have lower extremity and posterior calf complex related issues. And this would include tight and painful calves, Achilles tendonitis, heel pain, plantar fasciitis, runner's knee, and iliotibial band problems. This shoe has as I said, a high energy return. So with the high energy return and its weight, we would probably put that into a fast for performance in the fast category. We usually grade it from a slow, medium fast, fast, and ultra fast. For a recommendation for the shoe, because of its negative loaded heel to toe drop and being in the neutral stability category, we would recommend it for neutral to mild pronators of light stature, void of posterior calf complex, and lower extremity issues. This is more of a shoe, performance shoe, for elite and well-conditioned runners. Casual runners probably do not have enough strength and flexibility in the lower extremity to make up for the lack of stability in the shoe. Again, this is a very interesting shoe, and how could it be improved? Well, I believe that the shoe could be improved two different ways. First of all, the insole is too soft, so you're losing a lot of hindfoot stability. So if it was firmer, you would get a better hindfoot stability. Second of all, it lacks vertical support. So they need to have this firmer, and they should raise the heel 2 or 3 millimeters. And that would give better vertical support, and you'd have less injuries in the posterior calf complex area. Evaluation of the shoe, taking into consideration structural parameter testing, clinical evaluations, and our knowledge in the mechanism of for injuries.